All right, well, for those who don't know me, I'm Bartley Gillen. I'm the organizer of the Austin Hardware Startup Meetup. And actually, my co-founder, Ryan Brown, is here somewhere. We started, there he is in the back. He and I started this back, I guess, November of 2012. The idea came about, and then we launched the first meetup in January 2013. So it's been exactly 1 year's worth of meetups. And honestly, didn't expect to keep going this far, but you know, why not? There's more people who keep showing up, so we'll keep it going. Ryan himself moved out to Los Angeles to work for Oculus Rift, and whoever doesn't know about Oculus Rift, then you need to read up on your hardware news.
You want a job? Come talk to me.
Yeah, they're hiring a ton of people. Last time I looked at their jobs page, they had at least 50 openings, so unfortunately not in Austin. But they do have a software team in Dallas, and I think the rest of the hardware team's out in Orange County on the beach.
Thanks, Bartley.
No problem. So yeah, it's been an impressive year. I just whipped together this slide earlier today, but we've had 15 meetups, one every month, and in the month of March, due to South by Southwest, we had three total actually, and a total of 13 sponsors. All of their logos are on this page. And a total of 37 presenters. That includes people who did demos, some of the sponsors who gave presentations, and other formal presentations. Total member counts 514. 1 year ago, that was 0. So impressive growth rate, yeah. And I think I found about 9 companies that were here that are Austin-based, and I just Googled all of them and found out how much they raised through Kickstarter and Indiegogo. And that figure is $2.7 million, which is fairly impressive. I mean, last year I know significantly less. Part of that's due to, you know, hardware is actually hot. It's been hot for about 2 years, but it's just getting better and better. And if you follow the news, you know, you see Google's acquisition of Nest at $3.2 billion, and that, you know, draws people's attention. So that, coupled with big VC rounds in the last year, Oculus Rift, you know, Brian raised $75 million, Series A or B?
B.
Series B, and I don't know, it's like 100 million total, and it's a lot. So, you know, Austin is mostly a town of software and semiconductors, but part of the reason why we started this meetup was to draw attention to the middle of the stack, that is hardware in the broadest sense, that is mechanical design, electrical design, just physical things that people make and intend on selling. So this group is about making things, yes, but also following through and selling them. So that's the challenge, right? You can make anything in your garage. I've made tons of stuff, but have sold very little. But getting to that next step of scaling up is really, really hard. And we have people here that have done that. You just need to meet with them. We have presenters and speakers that have talked about that. Of course, raising money is hard. Hardware is hard. This is not, you know, a group of software people. I mean, I'm sure some of y'all are out there, but you need more than laptops to do a hardware business. Moving on, we have, let's see, these are just the companies in Austin that I would consider hardware startups. Some are older, some are very young. Atlas at the bottom is actually still doing their crowdfunding campaign at the moment. They're almost $90,000 so far, and they have about 22 days left to reach their $125,000 goal, so I just want to plug them. They've given a demo here a couple months ago. They're a great group of guys. They're out at CES, you know, just beating the streets and trying to get press and, you know, do whatever you can to help spread the word, because helping any Austin hardware startup helps you and me and everyone else in the long run here in Austin. To take a look, there are some logos here that have not presented yet. I'm going to work on trying to get those guys here. Specifically, Brigo is pretty cool. They do a robotic coffee machine. If you've ever been to the UT campus on the western side, there's a building there that they have that. I think they've been demoing for about a year now, but they're trying to scale up. Couple other ones. A lot of these are Kickstarter based. There's a couple that are massively funded. Tracking Point specifically, they they spoke here in December, actually, and it was like a jam-packed house. If you don't know about Trekking Point, they make this super sniper rifle thing that's just ridiculous, but it's so cool because that's, so anyone can kill you from 1,000 yards away, having no experience with sniper training whatsoever. They're an impressive company. They raised like $35 million from Austin Ventures and private people, and that's not even public. Obviously, because it's a gun. And what else? Yeti Coolers is an Austin company that I didn't even know about until about a year or two ago, and they got acquired back in 2012, I believe. I want them to speak as well, so if anyone has any contacts there, we can try to get them to tell the full entrepreneurial story, blood, guts, and gore, and everything. Smaller guys here, Blue Spray gave a demo. I think that's mostly a 1 to 3 man shop. Virtuix Omni is a Houston-based company, but also their technical teams here in Austin. They raised $1.1 million on Kickstarter just recently. I put them up here because they're at least partially in Austin. And I'm sure there's plenty more that I've forgotten about, and probably some people in the audience that I've forgotten about. If you want a demo, email me. We allow people to demo pretty much whatever, as long as it's the theme of hardware, not just purely a software play, or even if your customers are mostly hardware engineer types. We have an impressive next speaker I will get to after this. So South by Southwest in March, that's the time to shine for Austin and entrepreneurs, and South by Southwest Create specifically is the kind of hardware maker side of South by Southwest that is officially sanctioned by South by. However, you don't need a badge to go check it out. So this year, it's not going to be out east of I-35 or east. It was in a parking lot last year, but I think there's a hotel being built there now. However, it will be at the Long Center. I talked to the organizer, Aaron, and he is encouraging more people to show off their projects. So if y'all have like a cool demo, I mean, anything you're working on, it doesn't have to be launched yet. Just like how we like to show off what people are working on there. South by Southwest is obviously a much larger venue with tens of thousands of people in town that could help you out with your product or with your skills. So I definitely encourage you to Google South by Southwest Create. They're still taking proposals. I'm going to send out a follow-up email with details and links to that stuff. And next, 3 weeks from now, we have Dragon Innovation actually coming to town. They're going to stop by Dallas and then pop into Austin. And if you don't know about Dragon Innovation, then you should do some research because they're kind of the people you need to go to when I spoke about manufacturing. So if you've never manufactured a product before, Dragon Innovation is the company that you contact first and that reviews your design, make sure you have a manufacturable design. They can help you with the crowdfunding side. They actually do their own crowdfunding on their site to compete with Kickstarter. The advantage there is it's like vetted and they can actually predict in a realistic way when you are going to actually be able to manufacture a product. A lot of people think, oh, I can manufacture this product a few months. Nope, you should think 6 months, absolute minimum. Realistically, it's more like a year. Scott Miller is the CEO there, founder. He also, his background was with iRobot, and so he actually did the manufacturing bring up in China with iRobot, and then has helped out a ton of other startups. Pebble, I don't know about if Oculus uses them. I'm guessing no. Ryan's shaking his head. But any major hardware startup recently, the past year or so, uses them, so they're kind of like the go-to shop in town. Actually, they're not in town, they're in Boston, but he's flying in, so if you want to meet this guy, be there 3 weeks, just check out the Meetup. It's actually on the Meetup site. I haven't announced it yet, but I'll blast it out either tonight or tomorrow. And after that, we have our main speaker, which is, yeah?
Austin Mini Maker Fair.
All right.
Okay. May 10th.
May 10th, Austin Mini Maker Fair.
Yes.
A little further out, but that's another great place to show off your projects.
Town Hall is going to be held coming Monday. The call for makers will go out the coming Monday. Town Hall
Town Hall Monday, Call for Makers the following
will be
Monday.
held at North Door.
North Door. Okay. So Austin Mini Maker Fair, if you didn't hear that, another place. It's not the official Maker Fair, but it does attract a huge crowd. I presented there actually last year, and it's great. So definitely check it out. There's a lot of hardware stuff going in town, and that's actually a couple other groups. Dorkbot, ATX, if y'all haven't heard of them, they're a little less commercial, but more hackery style. We help like cross-promote them every now and then just because they're a good group of guys. Finally, I'm actually looking for a job due to recent employment changes. So if anyone has a connection and hiring, wants to do something cool, just let me know because I have an abundant amount of free time, which means I can devote it more to this meetup. But this is mostly an active service. So yeah, let me know. I'll email out details and stuff. What's that?
What do you want to do?
That's a good question. Background's electrical and mechanical prototyping, really. We can talk later, but I'll get the featured speaker tonight is all the way from Italy, actually. So I don't want to give out too much information, but obviously the theme is RFID, and we have some special guests from across the pond. And with that, I will pass it on to Maurizio to explain more.
Thanks a lot. Well, my name is Maurizio. So tonight we're going to talk to you about this Italian company, and we came all the way. We have a couple of Italian guys that are there, plus myself. The delicious pizza you're enjoying, we made it today. So that was a little bit of a stereotype, but so anyway. Again, Maurizio, I'm based here. I'm in San Marcos. Work for a company. I'm the U.S. sales representative for Kind. Yeah, one of the distributors. I work for a different company. But we distribute their products here in the States. Over there's Stefano Coluccini right there. If you can spell his name, we're going to give you a free pizza tonight. And he works for Kind. It's the chief of marketing. And David right there is also from Kind. He's a sales engineer and janitor. So, anyway. A little bit about the company real quick. So Italian-based, founded in Italy. Originally, back in the 80s, that's what was first started. The company itself did not start with RFID. It started with very unique, specific hardware for a nuclear physicist. Okay, so the research in the nuclear physics field. So if you go like to the CERN, the place where they do all the research on physics and nuclear particles, they need to have very precise power supplies, and Kind makes those. Okay, so those things are the main core business of Kind. However, back 2 years ago, 2003, they created a spin-off, pretty much like, and Kind does that. They have several divisions, semiconductor and all that, but they like to spin off companies. So Kind RFID was one of those spin-offs. It started, the funny part is, at the time when they started RFID, in Italy, they were not allowed to sell RFID. Okay, so they actually had most of their sales around Europe, because in Italy itself, RFID was the frequency which RFID works, the UHF RFID works, was not available commercially, so they had to rely on selling things outside of Italy. And then a few years later, finally they opened up and they were able to start selling in their own country. So 90 employees, again, like you can see, most of them on the nuclear field. So, but this is a hardcore engineering company. We're going there, there's lots of engineers, and all they do is building things from scratch. Very good knowledge, very good know-how on electronics. So, companies in Reggio, Italy, if any of you know what it is, it's an essential part of Italy on the west coast. It's a beautiful seaside town. again, kind of was really the first. Again, mainly because nobody else could sell product in Italy, so nobody really invested money on trying to develop hardware to cover the UHF RFID stuff. So they were the very first one to do that, and that's when they started. In the EU, in Europe, it's a well-established company in that field. They have a lot of customers, and it's a pretty good market for them. In the US, there's a lot more competition in that regards. There's company large and small. Some of them, you probably know Motorola. It's one of the competitors, but you know they established themselves quite early, so I mean, they have a pretty good grasp on the market there. Over here, we are expanding, and our products are, and you know, Stefan will take a look at that later, but you'll see our products are pretty unique and pretty specific to certain applications. So that's where they usually compete there with other companies. One big thing of us is just, I mean, selling hardware to other manufacturers. Okay, so we have our OEM products line, and that's the product line that we really count on. So okay, we want to give that to other people to create products around that. Okay, so to use our RFID technology creatively to build hardware that is meaningful in the market, and can be developed. So RFID is not new. You guys, if you guys know a little bit of history of RFID, or at least understand RFID, I mean, it's been around for a long time. Okay, one of the main things was back in World War II, the British realized that they were shooting down their own planes. So and now you have all these bombers coming in with all these fighters behind, and they were trying to shooting down the Germans. They were shooting down their own bombers. Okay, so they said, well, we need to have a way to identify those planes better. So they developed these big old transmitters, and they were basically transmitting down and say, hey, I'm a British, don't shoot. So and that's what they did. So that's where the technology started, a nascent concept. The idea of identifying objects. Okay, that's where the RFID started. And then it'll be the history, a lot of development throughout the world, back and forth between Europe and US. And that's where we are today. You guys know what's going on right now, especially in the UHF field. You go to Walmart, Macy's, JCPenney's, most of the big box stores. You find a lot of items that are tagged, okay? They all have RFID tag attached to it. They're used for inventory purpose. So this concept about, finding what you have in stocks and what is your real inventory, that's basically technology that RFID enables you to do that. And so it's becoming really, really relevant, and it's spreading around, and you're gonna very soon find in pretty much everything you have on you. Tennis shoes, Adidas, they start to tag all of the shoes. The tags are embedded into the shoes, okay? So, you can read it with your phone with NFC technology. So again, the RFID technology in general is becoming very pervasive. It's around us. So another example of history. So basically, the good old CIA decided that it was a good application for spying. So they put an RFID device on one of the gifts they give out to school kids. So they were able to retrieve information that way. So it was basically the first example of large-scale technology. So a passive tag that doesn't have a battery on board, but because you radiate enough energy towards, is able to wake up and send back information in a way. So that was the first example of it. Working in principle, I think it's time perhaps for Stefan to start. He's going to give you the all more technical details and all that, and he's going to guide you through the product line of time. And so we're going to, Stefan is going to start on that.
Okay. Thank you very much. Okay. So yeah, just a few words about the working principles of UHF RFID and backscattering technology. Maybe some of you already have an idea of how the RFID works. This is just a very simple sketch on how it can be understood the backscattering technology that is very similar on what it happens on the radar technology. So on the radar technology, you are able typically to determine if an object is big metal object or a smaller metal object, and that is based on the amplitude of the reflection of the signal. And the RFID UHF is very similar to that. So the tag, the label, has an antenna that can change its own characteristics, and so it can be seen as a big object or a small object. And that modulation make possible to communicate information, so 0 and 1, and that is the basic of the communication between the tag and the reader. At the same time, with the signal, we are now able to power on the chip that is very low power. That is why UHF RFID was born just in 2000 years, because of the advanced technology on low power chips make it possible to power on the chip only with the radio waves. So at the end, you modulate the amplitude of the signal and you get information, just very, very simple. So why, let's say, we have seen a little bit of history of the RFID technology coming from the LF to the UHF technology. But why only now we have those news and those big installations on the Macy's and Walmart, as Maurizio said, is because of two things. One is UHF, that makes it possible to read the text from long distances. Long distances means meters or I don't know, in feet, what could be yeah, something like that, 30 feet. So I'm sorry, usually we don't use feet in German people. So that makes open new application for the RFID, and that obviously is possible with passive tags. So means just a chip plus an antenna without any battery or anything else. So this opens new application, and typically the application that makes the technology, so the killer application for UHF RFID was the possibility to read a complete pallet of goods with just passing through a gate with 4 antennas or something like that. So the distance and the possibility to read through the card box, for example, so without the line of sight, like is possible with the barcode, makes the RFID technology so famous as it is now. At the same time, a lot of big companies make interest on this technology for the optimization of their processes, and so now we have those big installations. So an RFID system is not just a tag and antenna and reader. We have also software behind, so a complete installation is not as simple as reading text. You have to get the information, filter the information, put information in the ERP systems, and so on and so on. Just a bit technical information about the difference between different type of RFID. The main difference between the old RFID technology and the new UHF RFID technology is the usage of electromagnetic coupling instead of magnetic coupling. And in the LF, HF, RFID, we use magnetic coupling, and so the interconnection between the tag and the reader is just like a transformer that makes from 110 to 5 volts, for example. We use the same technology of transmitting the current using the magnetic field. That means short reading distance, short communication. With the UHF, you have like the cell phones or the TVs. So that is the type of the communication that makes it possible to communicate in long distances. This has a strong influence on the design of tags. That was one of the key points on the success of the UHF RFID. As you can see from these photos, you can see here the UHF tags that are very simple. There is a chip glued to a small antennas that is mostly linear. On the other side, you have the HF and LF tags, and you see the chip is connected to a number of coils. That makes it complicated to build tags, make it expensive. So it's not possible to make an installation with billions of labels like we have today in big retail chains. That is not possible, not only because, in electronics, if you make million things, you can make it then very cheap. But it's not only this, it's also about the complexity of those things. And UHF tags are very, very simple. You have just a strip of typical plastic with some metal on top and 2 point of glue and the chip. And that's all. You have a tag. And that opens the application for big retailers together with the long range. So at the basis, that is the technology, the frequency you can use to read and the technology behind. But one of the most important things is how you encode the data inside the tag, because that is what the retailers are using to identify their object. And you need a standard, because as in the barcode, you have the producer, you put the code in your product, and you want that the retailer use the same code without renaming the thing. So there is a complete set of standards that cover also the managing of the codes and the assignment of the codes to different companies and different products. And that is an example on how the EPC code is constructed. This is very similar to the barcode. So at the end, now we are a bit, let's say from the start, it's about 10 years that the UHF technology is becoming more and more popular. So as you can see here, for many different type of form factors for tags, they are all sharing the same protocol, the same frequencies. They can be read with the same readers and so on. But you see a lot of different things. This is because there are a lot of different applications. Just to say something, for example, the one there on the corner is just a standard label, but made with material that can resist a very high temperature. For example, when they need to paint things in the oven or something like that, or you have tags for metal that are hard tags that can be hardened without broke and so on, or you have this strange thing with the since a spine that is used to be inserted inside the wood for identifying pieces of wood or other type of tags for many different applications. Most of them are for retailers, for to be attached to an object of clothes and so on. So just to say, there are a lot of different applications for UHF RFID, and after me, David will give you some example of those applications. So just to say something about the standards, this is the standard for the tag. It is called EPC, or EPC Global Electronic Product Code, Class 1 Gen 2, because it's the second generation of standards, and it has some characteristics from the rewritable EPC, user memory inside the tag, some commands to kill or to put a password for protecting data, and so on and so on. One nice thing is the possibility to kill the tag, so to make the tag broken at all. That was born because of some privacy issues. People started to tell, let's say, if I exit from my shop with my things, maybe I'm a man and I bought pink slips, and I don't want the other to know that, and to be someone around with a reader and can read that I buy something strange. So they would like to protect the privacy of people, and so there is this kill feature that in principle, at the exit of the shop at the cashier, you kill the tag and no one else can read the tag after you exit from the shop. At the same time, you can lock the information not to be changed, and so on and so on. That is the structure of memory. So it's a very simple structure with 4 banks of memory. Each bank has a different usage. So the most important one is the EPC, that is the place where I put the code for the code that identify the object. Then you need the server for the passwords, the TID for identifying uniquely this tag, and the user memory, mostly using the special application where you need to store more information than just the code. but 90% of the application, when you just need the code and you have a database and the ERP system, you have all the information. You don't need the use model. So let's say that was very quickly an overview of the technology. Coming to the product we have, as Maurizio said, we have quite a huge catalog of products, but one of our strength point is the OEM, the embedded readers, because we provide the founding technology to other companies to build RFID readers. So those modules are 4 different ones up to now in our catalog, are building blocks. You get this, you have a complete reader, you just plug an antenna, you connect the connector to the data and power supply, and you have all the functionality of an RFID reader. When you talk about readers, it's because of jargon, but a reader can also write, can also log, can make all the things that are foreseen in the protocol standards. So with those blocks, we provide them, for example, to printer manufacturer, to handle manufacturer, but also to company that wants to implement the RFID inside, for example, industrial automation machines or along the production lines, and so on and so on. So we provide the founding technology those to apply the UHF RFID technology to their processes. Just going quickly, we have also other type of readers, obviously, readers that can be installed as a standalone reader. You pass through with the pellets or with the goods and you read. Special readers with the intelligent inside. That one is a PC with the reader together in the same box that make easy the installation. Or what you call it, application-oriented readers. So, for example, a portable reader, a desktop reader, because the application of the RFID becomes widely adopted and pervasive in many applications. So you need different type of readers for an application. Just as a last product line, we have also a special tags. We typically do readers because it's electronics. Tags are mostly for who makes paper, because the labels are made of paper. 99%. But there is a special application that we found out that is the cold chain, so the controlling of temperature for perishable goods along the transportation. Nowadays there are some different type of temperature loggers or temperature indicators, that both chemical or electronic. What we have is an electronic temperature logger. The difference with the others is that it has a standard UHF RFID interface. So you have a temperature logger that stores the temperature logger along the transportation, temperature data along the transportation. At the end, you can read the data using just a standard RFID reader. Not only kind RFID reader, but just a RFID reader that is compliant with the EPC class 1 Gen 2 standard. So that makes possible the integration between the supply chain, the track and trace of goods, plus the controlling and the temperature with the same technology, with the same infrastructure, without adding new technology, new things, proprietary technology around. You just use the same readers you use for your inventory process, also to read the temperature data. And we are proud to say that DHL chose our technology to implement their temperature monitoring service for their transportation. So they have a complete service for biopharmaceutical companies. They have just an account, like when you put your tracking number inside the systems and you see all your package history with the checkpoints where you pass it through. Then with this, if you sign up for the temperature control service from DHL, in addition to that, you get also the temperature information attached at each checkpoint. So that's details, I think it's not important. So yeah, that is just a brief introduction. I would like to call David to talk about our partners and some example of application we made. Yeah.
How much do the temperature logging tags cost?
The night's about 20 euros. That means 30 $1 maybe. Yeah, something like that. Yeah, but it's yeah, we're working in a new version that will be cheaper because nowadays this price level is quite good for pharmaceutical. If you compare with electronic USB loggers, they cost about $100. They are multi-use, obviously. So our are also multi-use, and they already cost much less than USB loggers. But for example, for food transportation, where the price is more sensitive, they need lower price. So we're working in the integration of all the electronics in a single chip in ASIC. As Maurizio said before, in Cannes we have different branch in the company, and one of these was a microelectronic design center. So we use this center to design an ASIC that embeds all the electronics in the temperature logger to make it cheaper and simpler. So that was next year maybe in the chocolate. Yeah.
Does the temperature logger require any sort of power besides what the RF signal?
Yeah, exactly. It requires power not because of the transmission, but because when you put the logger in the box, for example, and you send with the transportation, you don't have any reader powering it. So you need a battery to power on the sensor and the microcontroller that makes it wake up every, let's say, 10 minutes, half an hour. And
will it run without the battery if you just have a reader nearby?
Not this version. There are some versions that also make this, but yeah, we found out that it's not useful because if you have a battery, you use it every time. And it helps, let's say, it's easier to read the tag if you have a battery. If the standard tags work without battery, if you have a battery, it's easier because you don't need to power on the tag, you just need to communicate. But it helps. And we need it for the sensor, so we say, okay, it's there, use it every time. Yeah?
You showed pictures of embedded modules a few slides ago.
Yeah.
What's the physical size of that? And, those. What's the physical size?
Yeah.
So afterwards we can.
And also, what's the power consumption on those
Yeah.
modules?
The smallest one, that is the one in the corner, 1 inch by 1 inch. That is very compact. This one is 1 inch by 4 centimeters. That is 1 inch and a half. One. And that one is 2 inch by 3. Try to convert it centimeters and inches, but it's quite complicated. The other one is a big one for full power applications, full portals, still embeddable, but it's like 20 centimeters by 10, something like that. Power consumption, okay. The best performing one, apart from the big one that requires cannot be battery powered. It requires a 4 watt forward mounted, something like that. That is very powerful. That one that is the best performing in a compact form factor. It requires a bit less than 1 amp at 5 volts, so 5 watt more or less, 4 watt more or less. The other one, the smallest one, that is still has very similar performance to this. It requires a bit less than memory is failing me sometimes.
2.7 watt at
Yeah,
maximum power.
2.7 watt at maximum power. And the smallest one is less than that, so it's very low power. It's 2 watt for 100, something like that. So yes, they are not very low power. They need some battery. That is because you need a lot of energy to be transmitted to the tag, to power on the tags on distances. So that's the problem. The question?
Are these just UHF or are they a lot of HF?
We are specialized in UHF. There are a lot of HF reader manufacturers around, and they were already when we started the company. So we decided to specialize in UHF. We are this vision of the UHF as the RFID of the future for logistics and retail, and so we decided to specialize in this. For HF, you can find a lot of starter kits from Texas Instruments, for example, NXP. All those companies are already, you buy a kit and you can make your own reader. It's very, very simple as a technology. If you want a basic reader, if you want a very complex reader, it will be complex, but for basic readers, it's very simple. So a lot of competition, not so much value to add for us in this market. So we specialize in UHF. There's a reason. Okay.
Hi guys. Since some of you was already sleeping, me too. So I will go very, very quickly on some of the integration that we made with our modules. So those are a few of our customers that are integrating the small OEM module inside their handle. This is Scientech Logic. They are based in Canada and they have been acquired by Motorola last year. Those are other handle manufacturer. This is from Korea, I'm Mobile. MediaTek is from China. Joytech is from Taiwan. TTNetcom is from Germany. So they all make ruggedized handle for industrial applications. Then we have some printer manufacturer like Custom, Microplex, and MacTech. And then we have, those are industrial product manufacturer. This is an intelligent refueling device. So this is for large companies that have a big fleet management. So they want to be sure who is putting the gas and if it's correct that is allowed to put the gas or not. So let's go through the case histories. I will mention just a few of them. This is a Kanban process made by ABB. So those are returnable containers that they use for shipping the material to their suppliers. So every time this box is empty, it passes through a portal, and the box is automatically identified, and the order automatically goes to the supplier. So when the supplier receives the box, it's filled with the material and ship it back to ABB. ABB scan the box, see what is inside, and where to put it on the warehouse. So this is the second one is for a roll cage tracking for a posti, which is the finished post. So they want to know real time where are all their roll cages. So they put some RFID readers into doors, into corridors, so they can check real time all the movements of the roll cages. Not so interesting. Another one is with IKEA. So we have automatized one warehouse of IKEA where they are shipping lamps to customers and they are receiving lamps from producers of IKEA. Then we have a project with Col Cafe, so they want to identify all the bags of coffee and know the tracking of the coffee and the origin of the coffee, so if it's original or not. Another project is with Malvi, which is a very big manufacturer of trousers and t-shirt in Brazil. So this is for controlling all the production of their clothes. Then we have a lot of projects for waste management, so automatic identification of the bins. So in Italy we have the door-to-door collection of bins. So each family receives bags with an RFID tag. So the municipality can bill you according to the number of bags that you throw away. And this is for controlling the parking in some restricted parking area near where we live, with Pisa. This is a fleet management control. They are transporting dangerous material. So they want to know in real time who is driving the truck and what is carrying and where the truck is. So everything is done by the RFID. This is for controlling the train at the train stations. So all the trains that are leaving and coming to the station. This is a project we made with Europcar. So they are checking all the cards that have been rented and also the cards from the employees of Europcar. This is the parking of Fiat. So all the new cars that are leaving or entering the parking have an RFID tags on the windshield. Fiat is able to track all the movement inside the parking. This is the same, but made with the bicycle in Cernusco-Sonaville, which is very close to Milan. Those are not so interesting. This is project in healthcare. So we have realized an intelligent trolley with RFID, and this is the trolley that the doctor uses into the hospital to visit the patients. So this is able to make a real-time inventory of the medicines inside. So the doctor knows if some medicines is missing or not, and he can refill it before leaving for the tour to the patients. This is also related to the same project, and is an intelligent cabinet that is able to make the real-time inventory of everything that is inside. So you can see if there is something that is expiring or it has already expired, and if some medicines is missing or not. Those are more or less the same. This is for tracking the tools of the for surgery with very, very small tags that I have there if you want to see them. Then what else? Those are projects for fashion and retail. This is a very, very huge bookstore in the Netherlands. They have, I don't know how many hundreds of books, and all of them are tagged with RFID. And this is very good for making the inventory. Before using the RFID, they were making the inventory in 20 people for all the weekend. Now they are able to make the inventory in 2 hours with 2 people. So imagine how much time they can save. This is a project that we made for La Rusmiani. I didn't know this name, but it's one of the most expensive shops in Milan. You cannot find anything that is below 1,000 euro, so that's why I didn't know it.
The rest is just a key fob.
Yeah. And they have tagged all the objects that they have, and they have embedded an RFID system through the outside of the door, because they cannot put the anti-theft column, the classic one, because they are ugly, and they don't want their customer to see that they are controlling them. So they have hidden the system of RFID, and they are able to see if someone is stealing or not the things. And then they can decide if stop the people or not. Because, for example, if someone has spent, let's say, 20,000 euros, they will not stop it if he's stealing a T-shirt, for example. It's like this. Yeah. This is a project we made for Unieuro, which is similar to Best Buy, say. So they are making electronic devices. They are reselling electronic devices. This is an interesting project that we made for fashion for 3 brands. They are Jet, Tennis, and Punto Blanco. They have made an intelligent display, an intelligent changing room, so that they can check what people is carrying inside, and they are able to make statistics on a single item. So if a single item has been approved in the changing room 50 times and never been bought, it means that maybe it's ugly or there is something wrong. So they can get information to the marketing department. Those are the projects that Stefano was talking about. So DHL, they are tracking all their transportation for the pharmaceutical market using the temperature logger. So they are providing the service to their customer. If the customer pays more, they can know if the transportation has been in the correct temperature range or not. This is the same, but for vegetables. This is more or less the same, but for vaccine. The same for chocolate with lint screw. So this is for quality of chocolate. This again is the same with Auchan and Parmacotto. So this is a real-time tracking of all the items that are going from Parmacotto, which is the producer, to Auchan, which is the distribution center. Yeah. This is a nice project that we made in the Rovaniemi, which is the Santa Claus village in north of Finland. So every children has a big card with UHF RFID. So the system can know where is the child, and pictures are automatically taken when the child goes to Santa Claus. So and Santa Claus has a small display that can read the name of the child. So It's called the sheet by name. So David, come here, and they say, oh, how can you know my name? Because I'm Santa Claus. So children are very, very happy. And so that's almost all. We have many, many other projects, but there's no time to talk about them.
Questions, anybody? Anything?
There's some things there, so if you
Yeah.
look at the.
We have readers and thoughts there, so if you want to have a look.
I have a question. You talked a lot about the applications you've already done. What's kind of next? What's the new developments that you're working on? Where's the growth?
You mean mostly is in fashion and retail. They are the most expansive market. Maybe because they have money, because they have a big margin on their items, so they don't care paying 10 cents more for a tag, because they have very, very huge margin. And another field that is going now very well is waste management, because now everything want to go green, so you can control how much trash people can recycle using your RFID, so you can have this tracking.
Anyway, looking at the future, we think that whenever the RFID will be widespread on many different objects, we'll start up new applications, especially for the consumer. Now it's more on business to business. So the user are mostly the companies making inventories, making statistics for marketing purposes, making all those things. But in the future, when you will have tags in your home because you bought objects, maybe you would like at your home to read a tag, go to the internet and get information about the product you buy. Probably mostly for the food, for example, you can have a pedigree of your food, when it was produced, how it was conserved, and so all the information can be shared on the internet. All the protocols made by the EPC Global are already in this sense. They developed a complete stack of standards, starting from the frequencies used to talk with the tags, up to the EPC, the IS systems, and they also developed the standard for a sort of DNS of the objects. So what they call it the ONS, Object Name Server. So that you get the ID of the object, you go on the internet and you get the page for that particular product with the serial number. So it's yours. It's not just a can of Coca-Cola, it's your can of Coca-Cola. It's not one. So that is the vision for next, let's say, years.
Well,
not tomorrow.
yeah, to connect that, because we was talking about fashion, and now fashion is really on the forefront of this. Because I mentioned about Adidas embedding tags into their shoes. Yes, they see the value in the technology to be able to create that connection with the customer. Okay, so by embedding tags in the shoes, you're able to track that shoe. That's your shoes, and that shoes has an identity embedded into it. So that's where they really see that connection between marketing and technology, and so that's why we really push it very hard. And so that's a good example. So, yes, it's available right now. You can buy the shoes and scan it, and you can see. You can go to the website. It will be your shoe. You can get rewards and rebates and all that. And that should be your shoe forever, pretty much. You can buy like that.
And anyway, you're seeing, for example, this strange application on the Santa Claus Village. There's a strange, what that nothing to do with the inventories or track and trace. It's something, an idea that comes in mind to one engineer making this project. And that's all. So the technology is very flexible and commits a lot of things. It's your imagination of people who have the knowledge of the technology and the knowledge of some process around. And say, yes, I can use this technology to solve this problem of to change the mind for the process and to change completely the process using this technology.
What distance can you read the passive tags?
It depends on the reader, it depends on the tag, but it could be up to 30 feet.
Can you amplify it? Can you increase the distance?
The problem is the maximum power that you can radiate according to the FCC regulation. So you cannot radiate more than a certain power. So you could read more, but you cannot. So a way to increase the reading distance is to have more sensitive chip and more sensitive reader. Let's say so far the technology lets
Bigger
you
antennas.
bigger antennas.
Like a repeater type.
Oh, you know.
Okay, like
Not know if you can use a reader.
I think that the cost of a repeater would be the same of the reader. So
You just place more in it.
Yeah.
there's actually a company doing that.
Really active.
No, they use passive tags. They put like repeaters
Yeah.
around the room.
The company really active uses active readers,
Active
passive
readers.
tags.
Yeah,
Yeah.
So it's
same concept. You
Yeah.
piggyback a bunch of readers.
Yeah, but that is more, you read with one reader and then you communicate the data wirelessly. So it's sort of repeated, but it's not really the signal from the text that is repeated. It's the information inside the text.
they flip it.
Yeah,
Yeah.
exactly. So yeah.
What's your accuracy rate like? Does it vary between the different devices, or what's the read rate, the accuracy? Does it vary between devices?
You mean the accuracy of the reading?
How many reads you can get?
Yeah.
It depends a lot on.
It depends on really a lot of parameters, but you can read 100 tags in 2-3 seconds.
Yeah, maybe more.
Maybe more, yeah, it depends.
It
on
depends
the-
really on the environment and how you use it and how the products are, tags are stacked together, for example, could be an issue.
Yeah.
So that's why, there's been a lot of research, but 10 years of research on, retailers, how to stock products on the shelf with their RFID, how to read with their RFID, how to use their handheld devices. I mean, this is an ongoing issue, make sure that people use it right. If you don't, yes, your read rate will decrease substantially.
And then one other important parameter is the tag, the label. That could be as small as 1 inch, square inch or less, and that you cannot pretend to read it at 30 feet. You read it at centimeters, it might be 20, 30 centimeters, 1 feet maximum. But you can have a tag like that. You can read that at 100 feet. Easy as best. You know, 100 feet is yeah, more or less, yes, a bit less. It strongly depends on a lot of parameters, different type of readers, different type of text. And when you put a lot of meters between the reader and the text, you have the environment. So you have
Everything can happen.
so obstacles, reflections. So it's not easy to say those numbers. It depends strongly on the installation of the environment.
Can you detect the direction, movement, and position of the tag?
Yeah, let's say there are several ways to do this. Having the direction is quite easy because you can put 2 antennas and you can read the first that has read the tag gives you the direction. So it's very easy. And another way is to calculate the RSSI, so the received signal strength from the tag. But this is not much reliable because the technology is passive. So maybe you can have a very low signal from a tag that is near because there is some reflection, and you can have a very strong signal from a tag that is more far away, but because it has a direct line of sight to the reader. So it's not much
really
reliable.
available. It can be done, but it's not really available. There are now new, we're working also now on some algorithms to try to make it more precise to zoom in, and also seeing the phase information from the signal coming from the readings. But this is something, in development. But there are ways of understanding the position and the direction of the
And what is, sorry, and what is the cost of the smallest reading tag? I don't know, basis of
200 euros, let's say.
200.
Depends on volume.
Depends on quantity, more than on module.
I think the cheaper for quantity could be even less than $200, less than $150, something like that. The cheaper one. The technology is still about it's expensive, mostly because the components used for these frequencies are quite expensive themselves. So it's not like HF, you can find a reader for $10. So it's very simple. Those things are much more complex components and still very expensive. So
for the temperature logger, is that a single use or is that something?
They are multi-use. Multi-use. You can delete all the memory at the end and reprogram them to start again. And you can work. The battery life is about 2 years, so you can reuse it as many times as you want for 2 years, unless the battery is locked down.
So it's an embedded battery that can be replaced, but it lasts for 2 years.
The embedded battery lasts for 2 years. Yes.
So if I'm reading through a pallet, like if you bring a pallet to a warehouse, is that going to require active tag or passive in order for it to?
Can you use the passive?
You can use passive all the way to a
Yeah.
full size pallet?
You don't need the line of sight. The good thing is if you don't need the line of sight, then you can read a lot of text altogether. So you have 100 text in the pallet. In the couple of seconds you pass through the gate, you can read it. Just you pass through the signals, they are talking down. There is an algorithm because I didn't show you those technology inside, but between the tag and the reader, there is an implementation of what is called an anti-collision algorithm that is very similar to what is used on the ethnic connection. The famous LOA is started with computer science. The LOA protocol that was invented by the Hawaii University for communicating between their campus. It was the origin of the Ethernet protocol. It's very similar to what is used now in the airplane. It's called the locked LOA.
So is there a way to like use one passive tag as a master pack list so that you can validate that it read everything in the pallet?
That depends on the software side. So if you can do that by the software, you can encode, let's say, master code on the pallet, for example, and the slave codes in the boxes and in the pallet, that you can decide to read only, to filter the reads, to read only the pallet tag, and you know that all the other tags are together. And that depends on the software implementation and how do you encode the tags. That is some, a lot of time they do that, just to speed up.
So for example, we made a pilot in Fiat and they are doing like this. They are scanning a pallet, they have a master tag that identifies the pallet and they need just to read 2 or 3 slave tags in order to say, okay, this is the pallet. So they made the association because the 3-4 tags that they read and the master tag. So it depends on the application and on the software you write.
Yeah, we're software supply chain software guys, so we're curious about integrating technology.
Tags only send back information, right?
Yes.
So, I mean, would you have a different version of a tag where, say, here's a reader, and you power them off, and they, let's say, exchange information, tag to tag.
Tag to tag and not changing information.
Let's say, it's, yes.
Let's say, tags, it's like, it's like a mirror, the light and a mirror.
Okay,
The tag is the same. It is a monolith to reply to the reader.
Anyway,
using 0 and 1.
let's say the RFID, UHF RFID was born for logistic vendors, so they don't need what to say. But that is in principle possible because it could be that the reader, just the reader. You can have a source, a carrier wave source, so you power on 2 tags, let's say, and one text could, if there is the right firmware, could modulate the current signal, and the other tag could understand the modulation of the other tag. So that is something, let's say, no one has already made this on the market. It's something was studied, there are white papers about that, principle of functioning. Let's say, I think there is not yet an application for this. In principle, it's possible.
Just material of science. It's not real. It's not real life for everybody.
There are no products working like that, but it's possible because it's a matter of modulation of text, and so you have the other tag getting this modulation, so that information that is modulated by another tag could be done. But it's not. There are no products in the market now.
And would you be interested in pursuing this if there was an application?
Yeah, if there is an application, could be interesting. But up to now, we have not yet seen.
Is anybody using them for tamper detection?
Oh,
So you build them into packaging type for tamper detection?
Yeah, like temper.
Yes, we made for containers. You mean
So
that?
the
You mean that?
Leave the lock on the container.
Yeah. And we made for application for cold chain where they wanted to check how many times the container was opened in order to see how many times the chain has been broken, because every time you open the box you break the cold chain. So we made the tag that you have seen with the temperature together with a contact sensor. So every time the container was opened, the tag was able to log this event. We made for a company that make transportation of pharmaceutical products.
But anyway, there are existing now the anti-tamper tags for containers that you can use to lock the container. And when you pass through gates, you can read if it was opened before or not. So that's something that exists right now.
All right. Thank you, King RFID. They just want to thank Meetup for grab any pizza and beer that's left over. They paid for it, so.
We made it.
Yeah, made it. Yeah, all straight from Italy. I'm going to send an email out later. Some people wanted a group or mailing list, some method of meeting, I guess, other members and bouncing ideas off each other when we're not here, which is generally once a month. I think that's generally a good idea. I'm going to send out a poll on the best way to do that, because some people, hate email and love Facebook and vice versa. So please respond to that email so we can know what's best to do with people communicating and connecting with each other. And with that, if anyone has any specific request, like you're starting a company with robotics, but you need someone that knows mechanical engineering, or you're doing an RFID company, but you need somebody that does the software side, I'll allow a couple minutes right now just to send out your requests. So anyone looking to meet a specific person or a specific skill set.
Yeah.
Yeah, go ahead. Later, you?
We're looking for a production engineer. We're building a 3D printing factory in Temple and Round Rock, producing 3D printed custom orthotics. We're based in New York. We have a facility here. I'm looking for an engineer who can be on the ground, help us build out the facility.
Cool. What's your name and company?
I'm Joel. The company is called Sols. It's SOLS.co. We're not public with our funding. We're VC backed out of New York. But you can shoot me a tweet, Joel Wish, just like it sounds.
Okay. If you're a production engineer guy, talk to Joel. Anyone else? Similar requests? Nope, nothing. All right. Well, thanks for everyone coming out, and I'll see you all in 3 weeks.